Imagine a place where gravity reigns supreme, a point in space where matter collapses in on itself, creating an abyss so deep and dense that not even light can escape its grasp. This is a black hole, one of the most captivating phenomena in our universe. Their gravitational pull warps the fabric of space-time itself. Stellar black holes formed from collapsed massive stars are scattered throughout galaxies. Supermassive black holes, millions of times the mass of our Sun, reside at galaxy centers. They play a crucial role in galaxy evolution, influencing star formation. When a massive star exhausts its fuel, it collapses under its own weight. This collapse compresses the core to a singularity, surrounded by an event horizon. Despite their mystery, black holes are not cosmic vacuum cleaners. They exert gravitational influence like any other massive object. In the constellation Cygnus, the Swan lies a celestial object that has captivated astronomers for decades. This object, known as Cygnus X-1, is a stellar black hole, a remnant of a massive star that collapsed in on itself. Cygnus X-1 is one of the closest black holes to Earth, located about 6,070 light-years away. Discovered in 1964, Cygnus X-1 was initially detected as a strong source of X-rays. These X-rays come from a disk of superheated gas and dust spiraling inward. This disk is formed by material pulled from a nearby blue supergiant star, HDE 226868. The black hole's gravity strips material from its companion, forming a hot X-ray emitting disk. Cygnus X-1 weighs 14.8 times the mass of our Sun. The story of Cygnus X-1's discovery takes us back to the early days of X-ray astronomy. In 1964, a sounding rocket carrying Geiger counters soared above Earth's atmosphere, aiming to detect X-rays from the Moon. To the surprise of astronomers, the instruments picked up a strong X-ray source originating not from the Moon, but from the constellation Cygnus. This unexpected discovery marked the first detection of an X-ray source outside our solar system, and it quickly became clear that this source, designated Cygnus X-1, was something extraordinary. Further observations revealed that Cygnus X-1 was a binary system, consisting of two objects locked in a gravitational dance. One object was a blue supergiant star, HDE 226868, but the other object remained a mystery. The discovery of Cygnus X-1 provided the first observational evidence for the existence of black holes, revolutionizing our understanding of stellar evolution and the extreme environments that exist in our universe. Section 4. Stellar Demise, the birth of a black hole. Cygnus X-1's journey began millions of years ago with the birth of a massive star. This star, much more massive than our Sun, lived a fast and furious life, burning through its nuclear fuel at an extraordinary rate. As the star's core fused hydrogen into helium, it released tremendous amounts of energy, causing the star to shine brightly and expand into a supergiant. However, this stellar extravagance came at a price. The star's core, depleted of its hydrogen fuel, began to contract under its own gravity, eventually becoming so hot and dense that it could fuse heavier elements. This process continued until the core was primarily composed of iron, the most stable element in the universe. In a fraction of a second, the core collapsed, triggering a supernova explosion that blasted the star's outer layers into space, leaving behind a dense remnant known as a neutron star. However, the core of this particular star was so massive that even the immense pressure of neutrons could not prevent its ultimate collapse. Cygnus X-1, the stellar black hole, was born. Section 5. A celestial dance, Cygnus X-1 and its companion star. Cygnus X-1's story does not end with the formation of the black hole. It is locked in a gravitational dance with its companion star, the blue supergiant HDE 226868. This celestial waltz is a delicate balance of forces, with the black hole's intense gravity constantly tugging at its companion's outer layers. The blue supergiant is a massive star, about 20 times the mass of our Sun, and it is losing mass at an alarming rate due to the black hole's gravitational pull. This material forms an accretion disk around the black hole, a swirling disk of superheated gas and dust that emits X-rays as it spirals inward. By studying these X-ray emissions, astronomers have been able to determine that Cygnus X-1 is spinning incredibly fast, nearly at the speed of light. The interaction between Cygnus X-1 and its companion star is a dynamic and ever-changing process, shaping the surrounding space-time. Image artist's impression of Cygnus X-1 and its companion star HDE 226868.